Welcome Juddy production viewers to another video. In today's video we're looking at the Unit 3 General Maths course, the area study number 2, which is Recursion and Financial Modelling. Our topic is reducing balance loans and our skill is to examine some exam style questions. So let's have a look at some reducing balance loans. So we're looking at 3 exam questions from VCAA. So the first one's from the 2021 VCAA, and as it was known then, the further maths exam. Exam number 2, that is the short answer, and it's question number 8. So the question is as follows. For renovations to the coffee shop, Sienna took out a reducing balance loan of $570,000 with interest calculated fortnightly. The balance of the loan in dollars after n fortnights is S subscript n. Can be modelled by the recurrence relation. So we have initial value, S0, of $570,000, and we have a recurrence rule of Sn plus 1 equals 1.001 Sn, take 1193. Part A, we're asked to calculate the balance of this loan after the first fortnightly repayment is made. So we're trying to work out what's the value of S1 in this recurrence relation. The value, and by the way, we use letters such as, normally it's V for value or A for amount. In this case it's S. We can use any letter for recurrence relation. So S1 means after our first payment. What's the value of it after one iteration is the language we use. The initial value, S0, or the starting balance, is $570,000. And we're going to use the recurrence relation, S1 equals 1.001 times S0, take 1193. So that's taking the rule from our recurrence relation and applying it to calculate S1 from S0. Okay, because Sn to Sn plus 1 is simply going from one value to the next. So there's our recurrence rule to go from an S0 to an S1, our initial value to the value of the loan after one fortnightly payment. We substitute in our original value, S0, of $570,000. We multiply that value by the multiplication factor, also known as the growth factor, 1.001, and then we subtract our payment of 1193. So that tells us that after the first fortnightly repayment is being made, we have now a balance of $569,377. Exactly. Part B showed that the compounding interest rate for this loan is 2.6% per annum. Now the interest of this loan is built into the multiplication factor, that 1.001. Let's have a look. So little r is a symbol used for the interest rate per annum. That's our question mark. We know the multiplication factor is 1.001. And we also know that when we're talking fortnightly, that means that there's 26 fortnights in the year. So I've written here n equals 26. So the multiplication factor is equal to 1 plus the annual rate divided by the number of terms in the year divided by 100. So in this case, we're dividing by 26 because there's 26 payments in a year, which can be simplified to the multiplication factor is equal 1 plus the rate over 2600. Now we can try and solve this particular problem. So in this example, we see that the multiplication factor has a value of 1.001, and that's equal to 1 plus r over 2600. Now if I were to take 1 from the left-hand side and the right-hand side, I get that expression. Now currently, on the right-hand side of this expression, r is being divided by 2600. If I times both sides of this expression by 2600, I end up with r equals 0.001 times 2600. And that gives me an interest rate per annum of 2.6%. And that's what we had to prove. Question solved. Of course, if we didn't have to show our calculation, we could have simply used solve in brackets 1.001 is equal to 1 plus r over 2600, comma, r, close brackets. And that will give us the same answer of 2.6. Part C. For the loan to be fully repaid to the nearest cent, Sienna's final repayment will be a larger amount. Determine this final repayment amount and round the answer to the nearest cent. So for this, I'm going to use the finance solver. Let's have a look. So our first step is to calculate the duration of the loan. That is, how many payments do we need to make? So on the finance solver, I'm putting in the annual interest rate of 2.6 per annum. The loan is for a principal value or principal amount of $570,000, and it's positive because it's loaned to Sienna. It's positive cash flow. Payments being made by Sienna, $1,193, and that's negative because it's cash flow leaving Sienna to the bank. We want to find out how long it takes to pay it off completely, so the future value will be 0. We know being fortnightly, there's 26 payments per year, and there's also 26 compounding periods per year. So when I place that in my TI-Nspire CAS calculator using the finance solver, I end up with the answer for n as 650.0047. So that tells me it will take just over 650 full repayments or fortnightly repayments of $1,193. So in order to pay it out in total, Sienna has two choices. Number one, she can pay a little extra on this 650th final repayment, or number two, she can pay a very small 651st final repayment. Now note in the question, it states that her final repayment will be a larger amount. So she's going to opt for number one. That is, she'll pay out her loan after the 650th repayment. So let's now calculate that. So step two is to calculate the value of the final 650th repayment, which will be slightly larger than the traditional 1,193. And that's often the case with the final repayment. It's either be slightly larger or slightly lower than the rest of the repayments that are made. So we're paying it off in 650 fortnightly repayments, so n is 650. The interest rate is 2.6% per annum. The principal value is $570,000. The payment is $1,193 per fortnight. The payment per year is 26 because it's fortnightly. Compounding per year is 26 because it's fortnightly. So that means the future value for this loan will be $5.59 with a few decimals on the end. So that means at the end of the 650th repayment, the loan has a debit of $5.59. That is, it still has an amount owing of $5.59 after the payment of $1,193. So in order to pay off this loan in total, the 650th payment must have been the standard monthly repayment of $1,193 plus an additional amount owing of $5.59. So the final payment, that is the 650th repayment, must have been $1,198.59. Example number 2, this is from the 2022 Further Maths exam number 2, question number 8. To purchase additional workplace equipment, Pina took out a reducing balance loan of $580,000 with interest calculated monthly. The balance of the loan in dollars after n months, LN, can be modelled by the recurrence relation. So we see the initial term of this recurrence relation is $580,000. That's the amount of the loan. And we see the recurrence rule, that is L of n plus 1 equals 1.002 times L of n, take 3045.26. Part A, showing recursive calculations, determine the balance of the loan after 2 months. Round your answer to the nearest cent. So step number 1, let's calculate the balance after 1 month, that is L1. So L1 is what we're after. L0, the original balance, was $580,000. And there's our recurrence rule. L1 equals 1.002 times L0, take away 3045.26. So I sub in my value for L0, and I end up with the following expression. L1 is equal to 1.002 times 580,000, take away $3,045.26. So that means the value of the loan after 1 month, that is L1, is 578,114.74. We now take this value for L1 after 1 month of payment and substitute into the recurrence rule to work out the value for L2. So step 2 is to calculate the balance after 2 months. That is the value for L2. L2 is the question mark. L1, after our first step, has a value of $578,114.74. And to work out L2, we use the same recurrence rule. This time we're substituting L1 into the equation to determine L2. So we do so. It's equal to 1.002 multiplied by 578,114.74, and then we take away the monthly payment of 3045.26. We do that, we end up with a value of $576,225.7094. This question asks us to round to the nearest cent, so that becomes $576,225.71. Part P, let's determine the annual compounding interest rate for this loan. So R is the annual interest rate symbol. That's our question mark, what we're trying to solve. The multiplication factor in this particular rule is 1.002. And this is a monthly payment, so n equals 12. It happens 12 times a year. So there's the rule that relates the multiplication factor, capital R, to the annual interest rate, little r, and also the number of payments per year, n. In this case, the n was 12 because it's monthly, 12 payments per year. And that can be simplified to R, the multiplication factor is equal to 1 plus the annual interest rate divided by 1200. And we can relate that to the multiplication factor shown in the recurrence rule of 1.002. Let's take away 1 from both sides. And now let's multiply both left and right hand sides by 1,200. Leaving us with an answer of R is equal to 0.002 times 1200. This provides an answer of 2.4% per annum. And of course, we could have used the solve function as well on the CAS calculator to get exactly the same answer. However, had this question asked us to show or display the calculations, we couldn't just use the solve function, we'd have to use the steps as shown previously. Part C, the final repayment that is required to fully pay off this loan is smaller than all the other repayments by an amount less than $1. Determine this small amount in dollars rounded to the nearest cent. So step 1, we want to calculate the duration of the loan. That is how many months this will go for. So in our CAS calculator, we're going to place the interest rate as 2.4% per annum. The principal value is $580,000. It's positive because it's a positive cash flow. The payment is $3,045.26, and it's negative because it's a negative cash flow. We're paying the bank, or rather, Pina is paying the bank. The future value, we want to work out when it is fully paid off, so the future value will be 0. Payments per year is 12 because it's monthly, and the compounding periods per year is 12 also because it's monthly. And if we click now on the space using the Finance Solver for N, we find that this will take 239.99999 months to pay off. So it will take just under 240 full repayments of $3,045.26. So Pina has 2 choices. At the end of the 239th payment, Pina's loan has not been paid off in full, and so she has to pay additional. So if she were to try and finish this in the 239th payment, it would be a payment of $3,045.26 plus additional monies to pay it off. Alternatively, she could push it into the 240th final payment. And because the home loan is finished in 239.99999 months, this means if she pays a full 240th, she'll have some change left over from her $3,045.26. Note that the question states that her final repayment will be a smaller amount. Therefore, she pays out her loan in the 240th repayment. Let's now perform this calculation using the Finance Solver. So step 2, to answer this question, we want to calculate the difference in the value of the final 240th repayment. So she pays 240 monthly repayments at an interest of 2.4% per annum. Her principal, the loan was for $580,000, and her monthly payments were $3,045.26. She's paying 12 times per year, and interest being compounded 12 times per year. At our final calculation, after a 240th payment of $3,045.26, she has a balance of nearly 15 cents rounded to the nearest cent. So at the end of the 243 payment, the loan has a credit of 15 cents. So the 240th repayment to completely pay off this particular loan has to be 15 cents less than $3,045.26. Example number 3 comes from the 2023 VCAA Further Maths exam. Number 2, question number 5. Arthur borrowed $30,000 to buy a new motorcycle. Interest on this loan is charged at the rate of 6.4% per annum, compounding quarterly. Arthur will repay the loan in full with quarterly repayments over 6 years. Part A, how many repayments in total will Arthur make? This is quite a simple question. The number of quarterly repayments is what we're calculating. The number of years is 6. So the total number of quarterly repayments will be the number of years times 4, because for every year of repayments, there's 4 quarterly repayments to make. So in this case, we've got 6 years, and each year has 4 repayments. So that comes out to a total of 24 quarterly repayments. Part B, in this case, we're looking at the recurrence relation. So it says above Part B, the balance of the loan in dollars after n quarters, AN, or if you like the amount of n, can be modeled by the recurrence relation, where A0 is the original loan value of $30,000, and the recurrence rule is AN plus 1 equals 1.016, AN take away $1,515.18. Part B states, showing recursive calculations determine the balanced loan after 2 quarters. Round your answer to the nearest cent. So step number 1, let's calculate the balance after 1 quarter. That is A1. So A1 is the question mark. A0, the original value of the loan, was $30,000. A1 is calculated using the recurrence rule of 1.016 times A0 take away 115.18. So we sub in the value for A0, that being $30,000, and we get an A1 value of $28,964.82. So that's the balance after 1 quarterly payment, and we call that A1. Step 2, we want to calculate the balance of the loan after 2 quarterly repayments. That is the value for A2. So A2 is our unknown, that's our question mark. A1 was calculated previously, that's the balance after 1 quarterly payment. That is a value of $28,964.82. And of course, we can use our recurrence relation to calculate A2 from A1. So here we have our recurrence relation expressing A2 in terms of A1, and we substitute in our value for A1 calculated from step 1. So we substitute A1 is equal to $28,964.82, and that returns a value of A2, that is the balance of the loan after 2 quarterly payments, of $27,913.077. Now, when we look at the question carefully, it says we need to round our answer to the nearest cent. So of course, the 0.077 rounds up to 0.08 of a dollar or 8 cents. So our balance of this loan after 2 quarterly repayments, known as A2, is $27,913.08. Final part. Part C. The final repayment required will differ slightly from all the earlier repayments of $1,515.18. Determine the value of the final repayment and round your answer to the nearest cent. So we're going to use our finance solver. We know we're looking at 24 quarters, that is 6 years. The annual interest rate was 6.4% per annum. The principal value was $30,000, that is the amount of the loan. Payments being made were $1,515.18, and that's negative, by the way, because the cash flow is going from Arthur to the bank. Future value we'll leave blank for now. Payments per year is quarterly, so that's 4 times a year, and compounding period is also 4 times a year. The PPY and the CPY, that is the payments per year, and the compounding periods per year is always the same. So when we press enter on our finance solver, we end up with a future value of $0.1383, or if you like, 14 cents rounded to the nearest cent. So at the end of the 24th payment, the loan has a credit, because it's positive, of approximately 14 cents. So the 24th payment must have been initially a value of $1,515.18. However, we have a credit of 14 cents. So the final payment needed only to be $1,515.04. You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.